In addition to explaining how a child process can have a different view of the same virtual address as a parent process, virtual memory also explains how shared libraries work. When we have a shared library like image.so, it's written as position-independent code so that different processes can have that code at different places. The reason different processes might have an image at a different place is because they might have different sets of shared libraries that all want the same address, and it has to move them around. Each process in the system, though, has its own virtual table, so that one process can say, yes, image.s code, it lives at address hex A5,000, while some other process can say, I want that code to be at hex 74000. And even though both of those processes are running at the same time with different addresses for the program, it can be at just one place in memory. So this is why shared libraries allow different processes to be more efficient. They can all share the same copy of some code. If you remember how position-independent code works, then this image.so might call some other functions that are provided by different libraries or at different locations in these two different processes. And remember, it does that because image.so refers to a global offset table, which is at a particular relative address, but that's a relative virtual address. So in this case, for process 1, the linkage of that shared library can be described one way, while it's described in another way for process 2. Those different descriptions have to be in different places in physical memory, but they can be at the very next page in virtual memory. In fact, image.so, maybe we haven't actually called any part of that code in either of these processes. It doesn't necessarily need to be mapped into memory at first at all. These processes, when they start up, can say that they're using this shared libraries code at particular virtual addresses, and we can use the automatic on-demand paging to pull it in from the disk, only if the process actually uses the shared library when it goes.